Okay, everybody, welcome. We're going to spend tonight talking a little bit about your project on soil conservation. A couple of things that I wanted to discuss with you first is, I guess, what are the objectives? What are we seeking to get out of this tonight? My hope is that you'll be able to describe some of the problems that soil erosion has contributed to, explain ways that the activities that we have done as humans have accelerated the process. The project will hopefully describe ways to help for you to prevent erosion, and then obviously to explain how the amount of soil lost by erosion from a given piece of land is calculated. So, with that, let's take a look here first at some background before we actually get into the project. Okay, so in your lesson talked a little bit about soil erosion. Okay, basically that's the removal of soil, and it's a serious problem when we think about it. Is that it takes away a valuable resources that provides the entire planet a means to grow food. Okay, so if we looked at farmers in the central United States, if we're just talking about our country, they've been plowing grasslands to grow crops for decades to help with an increasing human population, not just in our country, but for what we export, to other countries. So when we hear things like drought that have occurred, throughout the last several years, um, it really has a profound effect on soil. So, when we're talking about, plowing the land for food crops, and over time, drought has a profound effect in that it makes land unsuitable for crops because topsoil blows away, and that's where we get in really into the soil erosion um, concept that we're going to talk about. Some other things that really have a major impact on soil conservation. The amount of water, the drought, the amount of wind that an area sees. Okay, um, is the landscape suitable for soil conservation? Does gravity play a profound effect on this? Okay, um, or not? In addition to that, we need to think about some things like agricultural management and the best practices that we see um, really with that. So, when we're thinking about best practices for agriculture, since obviously it's a leading contributor to soil erosion, and when you think about it, our country, probably 60% of our country, sustains itself with its own agriculture. We need to make sure that we take a look at some agricultural practices that can reduce soil erosion, and help us conserve soil. So, some things to think about as you're doing this project. We really want to look at how we conserve soil. So let's actually really get into the meat and potatoes of this. Okay. Um, what is the project talking about? Okay. You see here that the universal soil loss equation. Okay. What is that? So if we go back to April of 2002, the Agricultural Crop Rotation Act, okay, called ACRA, was adopted to protect water and soil quality, okay, and that was actually done in the Pacific Northwest. But I wanted to bring this as a point here. The concepts of the act are that regulated crops can't be grown in a field more frequently than once in 3 years or grown on land that has a slope of greater than 9% unless the crop is under the management plan by that actual Department of Agriculture and Forestry. Okay, so because soil erosion has become such a big deal, we now have these acts that are being adopted from government perspectives to help reduce or to help conserve soil and reduce erosion. Um, so the potential for erosion is calculated using this formula that you see here. Okay, and we call it the revised universal soil loss equation, or RUSLE, or RUSL, if you will. And the equation basically has a whole bunch of letters that actually are a means by which you can look at what's being what's being entered into the equation to determine the amount of loss. Okay, so if we take a look at the key here, A is equal to R times K times L, S, C, and P. Okay, so what are all those letters standing for? Well, you can see it right here in the key. A is a computed amount of soil loss per acre. R is the rainfall factor. K is the soil erodibility factor. L is the slope factor. S is the slope gradient, C is the crop management factor, and P is the erosion control management factor. Now, when you went through your lesson, it talked a little bit about all of these factors and what they deal with. So the scope of the project is for you to create a report, and it says 225 words. And frankly, I don't know how you could do this in less than 225 words, to be very honest with you. You're going to essentially tell me why each of these factors, R, K, L, S, C, and P, are important in that when you look at the amount of erosion that is occurring on a piece of land, what makes each of these factors so important that they have to get put into the equation. So down here it says, explain what would make each factor's value be high or low, and how each factor contributes to erosion. So let's break this down first, and then we'll talk about the guidelines. What do all of these letters mean? So in order to do that, we're going to just swing up to here. We're going to talk about the RUSLE factors. Okay. So when you're thinking about each of these, and when you do this, I'll talk about the format in a minute. But R stands for the rainfall and runoff factor. So think about, if you're talking about how does this play a role in the equation, the greater obviously the intensity and the duration of the rain, obviously you're going to have more erosion potential. And if you have less rain and less intensity, obviously the land is going to be drier. So that's going to lead to another factor, okay? We're going to talk about K, the soil erodibility factor. K is basically how susceptible your soil, or the soil that you're looking at, is to detachment and transport by rainfall and runoff. So sometimes there's very loose soil, and sometimes there's very tightly packed soil. So that's going to play a role. The texture of the soil is going to play a role in whether or not there's going to be high or low erodibility. Okay. And it just depends on the soil. If it's like clay, that what we have here in southeastern Pennsylvania, it doesn't erode very quickly because it's tight. Excuse me, it's tightly packed. If there's a lot of loose organic matter in it, the soil is going to be a lot more easily affected by runoff. If we look at the slope length, or the LS, okay, the slope length and the steepness factor, obviously think about it like a triangle or a block or an incline. The steeper and longer the slope, okay, the rise and the run of the grade, the higher the risk that you have for erosion. Why? Because as more runoff and more rain comes, you have a bigger slope and a longer slope for it to run down from, okay? If you have a lower LS factor, then obviously that's going to play into you're going to have less erosion. Okay? The crop management factor. This is where they talk about it's used to determine the relative effectiveness of soil and crop management systems in terms of loss. So the crop that's grown, the type of timing, and the way that you till the land, all has an impact onto whether or not the soil is going to stay put, or whether it's going to be susceptible to the other factors that we've talked about: the slope, the wind, the rainfall, the runoff. Okay, and then finally the support practices, and that this part of the equation basically compares the soil losses from up and down slope farming to the losses that result across entire parts of cultivation. So for what we're looking at here, if you have a low support factor or a low support practice, then you're going to have an increase in soil erosion, where if you have a high support practice, meaning that you're actually supporting the roll to help prevent erosion, then you're going to have a lower instance of erosion. So, what you really need to do for this is you need to look at each factor, look at what it's being explained here, and then think about it from a logical perspective of, oh, if I have farmland that's this way, is am I more susceptible or am I less susceptible to having the soil erode away? So that's essentially what this project is asking you to do. Okay, take a look at each of those factors, determine whether or not each of them are gonna provide an instance where there's going to be high soil erosion or low soil erosion, um, and explain that to me. Okay, so how you do it? I really am flexible with this. If you want to give me bullet points, you can give me bullet points. It says that it wants paragraphs. Um, what people have done in the past, and I think that it probably will help you with organizing your thoughts. You can do, 6 bullet points, and each bullet point can be a paragraph. Okay, if you want, you can write me a full out report format if you'd like. It's entirely up to you. Um, but what I'll be looking for is, of those factors, of those 6 factors, R, K, L, S, C, and P, can you explain to me how each of those factors um, will make soil erosion more or less? Can you convey that to me using proper grammar and correct spelling, and logical flow, meaning that the paper that you do create or the bullet point that you do create isn't choppy? Okay, so that's what I'm looking for in this project. Okay, um, and where it says a minimum of 6 sentences in each paragraph, I'm not going to hold hard and firm to that. If it's 4 to 6 sentences, you have, by my definition, completed the requirements of a paragraph. And with that, if you do find that you're still struggling with this, please come into the virtual office and see me, and we can certainly talk a little bit more about what the project is looking for. But that's basically the gist of this. Okay, 200, 200 to 500 word report, I would say, somewhere in there. If it's more than that, you're probably a little too wordy. Explaining to me why these factors contribute to high or low erosion factors, and that's basically the project. Any other questions? Email, call, come into the VO. I look forward to seeing you, and we'll be back here next week taking a look on how to break down another project.